Welcome to your weekly essentials, number 8, arithmetic and geometric sequences. So we're first going to talk about the formulas for these sequences, okay? And I'm going to write down the ones that are given to you on your EOC coordinate algebra formula sheet. All right, so for arithmetic sequences, we have the recursive and the explicit formula. So remember, there is a common difference that is important. So it's something you're adding or subtracting each time. So we have a sub n equals a sub n minus 1 plus your common difference. Now that's what's given to you in your formula sheet, but remember, you always need to write the first term also. So you need to write a sub 1 equals blank, a sub n equals a sub n minus 1 plus your common difference. Now the explicit formula is a sub n equals your first term plus n minus 1 times your common difference. Okay, and this one you need to simplify. This is the only thing you need to simplify, okay? So these are for arithmetic sequences. Geometric sequences, remember, has a common ratio. That's what you're multiplying by each time. So you have a sub, you always put a sub 1 equals blank, and then a sub n equals a sub n minus 1 times r. And then your explicit formula is a sub n equals a sub 1 times r to the n minus 1. So here are all our formulas that we need. And you don't need to simplify any of the geometric. All right, so let's just see. The first little section for the following sequences, write A for arithmetic, G for geometric, or N for neither. So we need to figure out, do these have a common difference, a common ratio, or neither? So if I look at number 1, let's just see if it has a common difference. Well, to go from -3 to -5, I'm subtracting 2. Okay? But then to go from -5 to -8, I'm subtracting 3. And then I'm subtracting 4. This does not have a common difference. So I know this one is not arithmetic. And remember, another thing you can do is you can take the second term minus the first term. You can even plug that in your calculator, and you get -2. But that -2 did not continue, so we know it's not arithmetic. Now I can take the second term divided by the first term to see if it's geometric, and I get 1.6667. But then if I do the third term divided by the second term, I don't get the same thing. I just get 1.6. So it's also not geometric, so this one is a neither. Now if I go to number 2, well, if you're thinking about geometric or arithmetic again, this would be adding 20 but then subtracting 20. Well, I know that's not right, so it's not arithmetic. But what are we multiplying here? 10 divided by -10 is -1. Am I multiplying by -1 here? -10 times -1 is 10. 10 times -1 is -10. So this is geometric, and I'm going to go ahead and write down my common ratio is -1. All right. Now number 3. Here, let's see. 26 minus 23 is +3. And does that continue? 26 plus 3 is 29, and plus 3. So look, this is arithmetic, and your common difference is 3. And then I look at number 4, and I see immediately that this does not look like it's arithmetic, right? We go ahead and we always subtract 200, but then we only subtract, just a little after that. So let's go ahead and try and see if this is geometric. Do 99 divided by 297. So 99 divided by 297 is 0.3333. And then if you're using the blue calculators, do second PRB, enter, and it gives you 1/3. So let's see if that continues. If I do 99 times 1/3, do I get Do I get 33? And I do, and guess what? 33 times 1/3 is also 11. So this one ends up being also geometric, and your common ratio is 1/3. Okay? So that's how you tell the difference between arithmetic and geometric. Then numbers 5 and 6, it's giving us the recursive formulas, and it just wants us to write the first 4 terms in the sequence, and then name the sequence. We just have to decide is it arithmetic or geometric. So, number 5, well, I'm going to go ahead and decide if this is arithmetic or geometric. We can just look at this formula. Since we are multiplying by 1/2, multiplying by something means it's geometric. All right, and it already gives us the first term, which is 200. So I'm going to put that in my first space there because that is our first term. Right? A sub 1 means first term. Now the second term, I take the first term and then I multiply by 1/2. Half of 200 is 100. And then I multiply by 1/2 again, which I get 50. And then I multiply by 1/2 again, which is 25. And then I would keep doing that if I needed to. Now number 6, we are adding 13. That shows me that it is arithmetic. Okay, so 1/2 was your common ratio. Positive 13 is your common difference. Okay, now it tells me my first term is negative 55. Okay, and then it's telling me I'm adding 13 each time. So negative 55 plus 13 is negative 42. Plus 13 is negative 29. And plus 13 is negative 16. All right. Then the next section, it's given a sequence. We have to find the first term, the common difference or the ratio, and write the explicit formula. So your first term is 20, and your common difference here. So if I do 13 minus 20 in the calculator, I get negative 7. So I'm subtracting 7, and it looks like I'm doing that each time. So my common difference is negative 7. Now, this is the one for the explicit formula I'm going to have to simplify. So I have a sub n equals your first term. Okay, and remember your formula, plus n minus, plus n minus 1 times your common difference, which is negative 7. So let's distribute this negative 7 here. So I have 20, and then negative 7 times n is negative 7n. Negative 7 times negative 1 is positive 7. And then our final answer, let's put this with our n's first. So I have negative 7n, and then 20 plus 7 is 27. And remember, you can check your answer here. If you plugged in like 3 for the third term, you should get 6. Negative 7 times 3 plus 27 gives you 6. All right. Now it tells us to find a sub 8. We're just going to plug in 8 for n. So negative 7 times 8 is negative 56. Plus 27 is negative 29. All right, then over here, your first term is 4, and then it already tells us a common ratio, so this must be geometric. Negative 8 divided by 4 is negative 2, so we're multiplying by negative 2, and it looks like negative 8 times negative 2 is 16, times negative 2 is negative 32. So your common ratio is negative 2. We don't have to simplify this explicit formula. It's just basically a sub n equals your first term times your common ratio to the n minus 1. And then when we plug in a sub 8, we get 4 times negative 2 to the 8 minus 1. 8 minus 1 is 7. So 4 times negative 2 to the 7th, and now we can plug that into the calculator, and we get negative 512. And then our last problem, number 9. Miss Chocoholic has been consuming many Snickers bars at an alarmingly fast rate. She has a snack box hidden behind her desk with many Snickers bars. Her students began to track the number of Snickers she was eating each day. On day 1, she ate 1 And then the students began to notice that the number was doubling each day. The students know that Miss Chocoholic gets really irritated when she runs out of her favorite candy. So let's write the first four terms of the geometric sequence. So 1, 2, 3, 4. Okay, well the first term says on day 1 she ate 1. Alright, and then it was, our keyword here is doubling. So this must be geometric because we're multiplying by 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Alright, so we know our first term is 1. We just found out our common ratio is 2 because we were doubling. So let's write the explicit formula. A sub n equals your first term times your common ratio to the n minus 1. And then it says if summer break is 10 days away and a student brought her 115 Snicker bars on that last day, so on that 10th day, if she has 115 Snicker bars, will she have enough Snicker bars to keep her happy? So we have, we want to find the 10th term because that's going to tell us how many Snicker bars she's eating on that last day. So 150, oop, no, sorry. We want to know if 115 is a good. So we have 1 times 2 to the 10 minus 1, which is 1 times 2 to the 9th. Oops. So plug it into your calculator, and I get 512. Oh my goodness. So if Miss Chocoholic was going to continue to be happy on that 10th day before summer break, she would need 512 Snickers. So the question says if she only has 15 Snicker bars, is that enough to keep her happy? No. She would need 512 Snickers to keep her happy. All right. Remember, if you have any questions on this, you can rewind, you can pause it, and make sure to ask your teacher if you have any more questions. Thank you. Bye.